Theory of relativity. This theory was introduced by Albert Einstein in early 20th century. According to this theory, space and time are woven together into a single fabric known as space-time, which bends and stretches depending upon mass and motion. It reveals that time slows down, length shrinks, and gravity is the warping of space-time, not just a pulling force. Quantum theory. Quantum theory breaks the laws of classical physics. It is the branch of physics that explains how particles behave at the tiniest scales, like atoms and subatomic particles. It shows that particles can act like waves, exist in multiple states at once, and only become real when observed, leading to mind-bending phenomena like superposition, entanglement, and quantum uncertainty. String theory. String theory is a bold idea in theoretical physics that proposes the tiniest building blocks of the universe aren't particles, but tiny vibrating strings like cosmic guitar strings, whose vibrations determine what kind of particle they are: electron, quark, etc. It aims to unify quantum mechanics and general relativity into one theory of everything, suggesting that reality may have 10 or 11 dimensions, most of which are curled up and invisible to us. Big Bang Theory. The Big Bang Theory is the leading scientific explanation for how the universe began. It proposes that everything started from an infinitely small, hot, dense point about 13.7 billion years ago, which then rapidly expanded to form the cosmos we see today. This expansion continues even now, and evidence like the cosmic microwave background radiation and the movement of galaxies supports this dramatic origin story. In short, the universe didn't explode into space. It created space, time, and matter in one colossal burst of becoming. Thermodynamics. Thermodynamics is the branch of physics that studies how heat, energy, and work interact within physical systems. It's governed by 4 fundamental laws that explain energy conservation, entropy, disorder, and the limits of energy conversion. Schrödinger's thought experiment. Schrödinger's thought experiment imagines a cat sealed in a box with a radioactive atom, a poison mechanism, and a Geiger counter. If the atom decays, the poison is released and the cat dies. If not, the cat lives. Quantum mechanics suggests the atom exists in a superposition of decayed and not decayed until observed, so the cat is simultaneously dead and alive until someone opens the box. Double slit experiment. The double slit experiment, first performed by Thomas Young in 1801, reveals the wave-particle duality of light and matter. When particles like electrons or photons pass through 2 closely spaced slits and hit a screen, they create an interference pattern, like overlapping ripples, suggesting wave behavior. But if detectors are placed to observe which slit each particle goes through, the interference vanishes, and particles behave like discrete bullets. This bizarre shift implies that observation itself affects the outcome, challenging classical notions of reality and hinting at the probabilistic nature of quantum mechanics. Theory of everything. The theory of everything is a hypothetical framework in physics that aims to unify all fundamental forces and particles into a single, coherent model. It seeks to reconcile general relativity, which describes gravity and the large-scale structure of the universe, with quantum mechanics, which governs the behavior of particles at the smallest scales. Current contenders include string theory and loop quantum gravity, which propose that space-time and matter emerge from deeper, more fundamental entities. A successful TOE would explain everything from black holes to atoms in one elegant equation, offering the ultimate blueprint of the cosmos.